Well, I'm going to make this a very short introduction because we were really fortunate to have Pip, Letitia, and Sherry with us last month when they talked about using photographs. And I'm going to turn it over to them, but before I do that, I just want to give a very personal introduction. These are three of my dearest and closest colleagues who I had the good fortune of working with on the writing team of the pre-K through 12 GAZE framework, second edition. And they brought so much to that document that was just invaluable. And they've continued to try to promote GAZE too by creating new activities, and they've been giving a lot of professional development for our teachers. So I consider it very fortunate that we've had them 2 months in a row. And I'm going to turn it over to them. And today they're going to talk about being curious. So the floor is yours.
Good morning, afternoon, evening, depending where you're calling from. It is only 2 o'clock and I'm out of Portland, Oregon. So Pip, Sherry, and I were really excited to dig into this topic of being curious with data. And I keep saying that I'm going to make this into a t-shirt, Data Curious, because that's the way that I see the world. We'll go ahead and move to the next one. And, there are a lot of word webs around there, and I understand that lots of stats folks aren't super fond of the qualitative nature of word clouds, but coming from the science community and working a lot with students, I am a big fan of qualitative data or categorical data. And when we look at these maps, we see statistics heavily represented, but our goal over the last session and this session is to think a little bit more of some of the moves that creep into data science as we think of using techniques to bring new data elements to our data sets. And the next one. So our outcomes today really is just a singular outcome, and we're going to introduce you to, or maybe you know them already, a couple of things. So we want to consider how curiosity is really an important part throughout a data investigation, and we're going to do this around volcanoes. So how we're going to do that is we're going to consider how do we create new variables. We're going to do lots of questioning of facts and authority, one of my personal favorite things to do. And hopefully you'll get an increase of understanding of some aspects of CODAP that allow us to have some fun with data. So we're going to start off just setting the stage for a moment about this idea of habits of mind. And virtual thumbs up or +1 if you're familiar with these habits of mind. They are a cornerstone of a lot of our conversations. But we're going to really zoom in on just the second bullet, which is this idea of curiosity, awareness, and identity. So I'll invite you to read this square so that way we can start with a shared understanding. So as we go through this session, you take a moment to think about how can I bring curiosity and ask more questions and be aware of how our personal experiences might impact the way that we perceive data. And this is a really important part because we know that children are naturally curious. And sometimes I've heard teachers say, I wonder where their wonder went. And so we want to stimulate that curiosity. And how we think that we can achieve that is by creating situations that have us as educators model curiosity for them, and that we highlight mismatches in thinking and observations between different groups, that we create opportunities for students to answer their own investigative questions, that questioning part that Pip has done so much work and support around is highlighted, that we encourage students to pose and ask questions. And there's so many types of questions. And this is definitely a great place for us to think about all the ways that questioning arises in our works. And lastly, probably the most challenging part is making space that are safe to ask all of these different types of questions. And the next one, Pip.
Let's start. Yeah.
It's not responding.
Not. There we go. Okay.
And the last comment before we hop in, something that a lot of our conversations, Sherry, Pip, and I meet on a monthly basis to kind of talk shop. And a lot of our conversations come back to this idea about ethics and how there is such a strong need for us to think about ethics all throughout the statistical investigation process. And whether that's with questions or collecting and considering data, or how we represent the data. And this idea of do good and do no harm is a North Star when we think about developing statistics investigations or working with data. And this has just been a really interesting idea. If you have a group of folks like this in a room together, sometimes we have blind spots in this area of what might cause harm. And so it's such a great opportunity to be together to help us learn from each other. We can move forward.
Oh, that's fine.
Woo.
So we're going to be thinking today about how we can think about curiosity, how we can harness our curiosity in a productive and ethical way. So recently there was a Freakonomics podcast about one of the most brilliant theoretical physicists, Richard Feynman. And it was highlighting his curiosity as one of his strengths. After achieving a perfect score on the entrance exam for graduate school at Princeton, he was the youngest one to be recruited to work on the atomic bomb. So in 1942, he was part of the Manhattan Project, and he was known for asking sharp, unrelenting questions about the science. So as Letitia referenced, there's many types of questions, and he did not hesitate to ask the difficult ones. So over 20 years later, he was asked to help investigate the Space Shuttle Challenger that exploded in 1986. And he was a little bit concerned because there was an aim to make sure that NASA was shown in a positive light. And Feynman was relentless in his questioning. He believed in taking risks, but he believed in taking calculated risks. And he would ask the same question repeatedly. And different groups had different answers. So management said the risk was much smaller than the engineers said. And he questioned the difference. As his daughter was going through some of his notes, she found this exact quote that's in the bubble. What is the cause of management's fantastic faith in the machinery? He noticed this difference in the risk that management and engineers calculated. And he was not afraid to question authority. His curiosity, coupled with his willingness to question authority, was the driving force in the investigation. But where did this curiosity come from, and how did he cultivate it? Maybe in part his curiosity came from interactions with his dad, who he oftentimes went on walks in nature with. He recalls one of their conversations while he's outside in nature, and his dad rattles off names of birds, a particular bird, in many different languages, and explains that that doesn't help you know more about the bird. It really helps you know more about people and language. And to really know more about the bird, you need to ask questions about and observe the bird itself. So we're going to start off today with a quick little investigation about names. And then Pip is going to lead us through a more in-depth investigation about volcanoes. So our own names identify us, and they have a deep personal meaning to us. And similar to photographs, we can use our name and coax data from our names. So let's start with thinking about what attributes you can create from a list of names. Here we have a prompt that was given to participants as they entered a session to create a name tag or a name tent. The driving question is, how does my name compare to those of my group? So take a moment, let's see what attributes you can come up with. Feel free to drop them in the chat, or if you're courageous enough, you can even unmute yourself and share it with the group. So what attributes could be generated from this list of names? So we might look whether people are male or female based on their name. It might not be a binary category because we might have a name like Taylor or Jamie that could be a male or female name. So the name length would be a quantitative variable. Oh, that's nice. The style that was used for writing the name. What does the name mean? Ah, Pip mentions she was named after someone. So we could have two of the same names that have the same meaning, but maybe one person was named after somebody and another person was not. Oh, the distribution of alpha characters, interesting. Whether or not somebody noticed that they were just asked to write their name on a name tag. Some people included their last name and some people didn't. So we could have a binary variable there, last name included, yes or no. And you can see how this is kind of a creatively stimulating process. Once we start with some like name length and we start getting outside of our initial thoughts, we can continue this into developing many, many different attributes. Awesome, great work. Let's take a look real quick at a list of some of the attributes that we or some of our participants have come up with in the past. So whether the name tent was folded hot dog or hamburger style, I think somebody previously had mentioned decor. We could look up the number of vowels or the ratio of vowels to letters. Interesting one, I thought, this last item on here, written by self or not. That was something that was identified as we were observing the process. So Hanny and Kate here, Hanny made both of their name tags because Kate wanted hers to look in the more formal calligraphy font. So unless we had really observed the process of creating the artifact, we might know, we might not have the same level of curiosity. So now that we've talked about different attributes that we could create just from one name, just from a name tent, let's go ahead and move on and think about how we would represent this data. How would we visualize this? So remember, our driving question was, how does your name compare to those of the group? And you might think about your attribute, and there might be different ways that you could present this in a visualization. So take a moment and list an attribute and the type of representation you might use to visualize your data. And if everybody says pie charts, we're going to have a problem. Oh, Mary mentioned a dot plot. I saw Michael mentioned he tells his students to stay away from pie charts. I actually did one time a debate with my students because I know Tufty, who is a big visualization guy, is kind of like no pie charts. But I don't know. I think every now and then they can have a time and place when there's not too many categories and people are very familiar with them and can read them. But if if you have a lot of categories and you're trying to really decipher how big one piece of pie is versus another, a side-by-side bar chart definitely would play better. Oh yeah, heat maps. So if one of your attributes was like the origin of the name, where did the name originate from? We could get a geographical map of it. But then we could also use heat maps to show frequencies and even think about Venn diagrams as representations. Awesome, great thinking. Well, we do want to, before we move on, we do want to share with you one of the representations from a small group of folks that we thought was pretty interesting and something we definitely didn't think of ourselves. I didn't know that you could classify letters as home, basement, or tall. Basement letters are like P's and G's. They go down below the line. Tall letters would be your same height as a capital letter, your H, T, etc. And this group did two different representations. So I like that from the NCTM's perspective of reasoning across representation. So you've got one data set and we can represent two different ways to summarize that data set. So they've got a bar chart as well as a Venn diagram here. So hopefully this has gotten your curiosity started and you're ready to engage that curiosity with volcanoes. real quickly before I hand it over to Pip for that, why names? And using names as the central piece of data to dig deeper allows students to investigate something that is personal to them. This type of investigation is great for any classroom because it's accessible. It allows students to be curious and it builds community. There's much more you can do with names, but we're going to move on and think about volcanoes. So I will hand it over to Pip.
Thanks, Sherry. And when I get a chance, I will try and remember to drop into the chat a link to some work that one of my colleagues in New Zealand has been doing around names as well. And there's a paper she's written, and she's Tongan, and it's really interesting about who gets to name children in Tonga. So it's not actually the parents that name, it's usually the paternal grandfather. So there's some interesting cultural differences also around names. Anyway, I'm going to start us off on the being curious about volcanoes, and this is sort of the second part of our thinking about curiosity in two ways. And I just want to talk a little bit about why we got to volcanoes, and really with the hope of saying, I'm sort of showing the thought processes that we've been through, and maybe will give you I guess the will or the thought that actually I can just take something and I can just go with it and see where we end up. So last year I was working with a group of teachers, and I had shared some data cards with them that I had. So I was using Monopoly data cards, who Gail Burrell had put me onto, and some super insect cards that we'd got from one of our local supermarkets was giving these cards away. And I'd shared these ideas with these teachers, and then the next time I saw them, Matt turned up and he said, I was using the Stat Attack cards, and these are the ones that you can see on the right-hand side of the slide. Now, these are New Zealand All Blacks and Black Ferns. So our national game is rugby in New Zealand, and our Weet-Bix is a breakfast cereal. And Weet-Bix always have something in their packs, and often it's things around the All Blacks. And so Matt had said that he'd use these cards with his kids, and he'd done some stuff with them. And I said, oh, well, did you look at it if there was any difference between, the number of tries that forwards and backs we got? And he goes, no, we just looked at the data that was on the card. So started thinking about this idea about being curious about the data that we've got and finding more from it. And so I started working on a unit of work where we built that up more. And then I wanted to connect to another topic that they were doing within their curriculum, another curriculum area. So he said, well, we're going to be looking at volcanoes soon in science, I think. And so then we talked about this idea of making stat attack cards for volcanoes. And so that was where it started. And then we started to prep for this session. And then we decided, well, will we look at US or New Zealand volcanoes? And then we got into having a little look on Wikipedia. So that's sort of like a little bit of a background about where we got to with what we've got here. So let's have a look. So in the chat box, now I don't want you to post. The really important thing is I want everyone to write something but not post. Apparently it's called a waterfall chat. So we're going to think about volcanoes in the US to start with. And these are two photos from last year when I was in Oregon. I'll just leave that as a hint for now, and I'll tell you what, you may know the two, but I'll tell you them shortly. But in the chat box, can you write what you know about volcanoes in the US, but don't post it yet? So just write anything you want in terms of thoughts, and then we'll all post together. Okay, so if you can now post, hopefully we'll get a bunch of one brave person. Cool. Washington history. Okay, so we've got different names for them. Lava ash dormant. Awesome. volcanoes in Hawaii and Washington. They've formed islands. All right, so we've got some ideas. So now I just want you to think, what do you wonder about volcanoes? So I started to write okay. Yeah, so what do you wonder? So you know some stuff, but what do you wonder about them? Do you want to write that in the chat, but don't post yet? What do you wonder about the volcanoes in the US? Okay, so let's post our thoughts about what we wonder. Nice. All right, so we've already got some initial thoughts about volcanoes in the US. So just when I think about statistics, and this is in my book, I really think about it as an opportunity for us to gain new knowledge about the world. And just in the time that we've been working on this workshop, which we've been doing for about a month since we finished the last one, I've learned a whole lot of stuff around volcanoes in Auckland, which is where I live, and we're going to look at some of that in a minute. But we have existing knowledge about the world. A problem arises, we undertake a statistical inquiry. This is our New Zealand form of your statistical problem solving, the PPDAC cycle. And then at the end of that statistical inquiry, we have new knowledge about the world. And so, the purpose of exploring the volcanoes is, one, kids need to know about it in terms of their science, but actually, hopefully it's a different way of getting this knowledge that they need. So that was sort of my connection to science. So we're going to now jump in and have a look at New Zealand volcanoes, because we decided that rather than do US volcanoes, which you are possibly familiar with, I should just quickly go back. The top one is Mount Hood, and the bottom one is Mount Adams, and the bottom view is the view from my accommodation when I was staying in Hood River last year. So yeah, that's just, I'm sure you knew that, but just in case you didn't, those are the two ones there. Okay, so here we go. This is Auckland, New Zealand. This is where I live. And this is Rangitoto Island. And this is the last eruption in the Auckland volcanic field 600 years ago. So this is Rangitoto Island. And I'm just going to go through a few slides just to give you a bit more of a context. So this is another photo taken from One Tree Hill. And I've labeled some of the volcanoes that are in the picture. So you can see Rangitoto Island there again. And then just a little bit about One Tree Hill, just in case you didn't know, the song by U2. It talks about One Tree Hill. That's our One Tree Hill there. So here's another picture. This is when I flew to Dunedin just after we were working on this. I thought, look, I can get another picture of our volcanoes. So Rangitoto, Browns, Mount Wellington, and Panmure Basin. And then I was on the water. I'm not always out and about like this, but I just happened to be. So here's some other photos of the volcanoes from another perspective. And this picture here shows you where those pictures were taken from. And for me, it was really about the point that Rangitoto, actually, it doesn't pretty much matter which way you take the photo, it looks the same. But we're going to do a little bit of exploration. And the pink ones here are a couple of islands we're going to look at. The purple are the volcano hills, and then the red ones are where it's a basin or a water body. So let's have a little look at them. So we're going to look at Maunga, Motutiri, and Wai. So those are the Māori terms for mountain, island, and water. And so we're going to start with this here. So when we started thinking where we're going to get our data from, we went into Wikipedia because they had a nice list of the volcanoes in the Auckland volcanic field. And I don't know, it just hit me smack in the face. They have all these fact cards. And I just thought, we're looking at data cards every time we go and look up a thing or a place or a location, they're both the same things, person. They have these little fact cards in Wikipedia, which in some ways are data cards. But anyway, these are 4 of the volcanoes, and we need to collect some data to add to our data set. So I have a question for you, if you can have a look at those 4 photos. And I think I want you to say, are we going to go for which ones do or don't?
It's a yes or no.
All right, so we'll start with number 1. Yeah? So
Yeah.
if you can look at number 1, I just want you to post in the chat, does it look like a volcano or not? Does it look like a volcano? Yes or no? So this one here, have a look at it and post in the chat, does it look like a volcano? Yes or no? Okay, all right. So number 2, Mount Eden. So we're going to, so no more on number 1. I think we've got a thing there. Number 2 in the photo here, does this look like a volcano? Yes or no?
Got 1 yes so far.
Cool.
And I'm actually collecting this data from the chat and inputting it into a data set we're going to look at. So
Yeah. Okay, number 3, One Tree Hill. This is this here. Does this look like a volcano? Yes or no? Okay, and number 4, Auckland Domain. Does this look like a volcano? Yes or no? All right, good. Okay, so we're going to move on. We've got quite a few to do, so we'll quicken up. But these are the ones we're going to look at. So then next one. So Mount Hobson, this is this here. Does that look like a volcano? Yes or no? Number 5.
ooh, this is the first one we've got split. 2 no, 1 yes. Okay, 2 and 2.
Oh, we've got quite a few for yeses on number 5. Okay, number 6. This is Mount Albert. Yeah. Okay, number 7. You can see it, it's behind the trees. This is Mount St. John. Okay, number 8, Mount Roskill. That's this one here.
Mary's trying to introduce a third category of somewhat or maybe.
Okay, number 9. This is Mount Wellington. This is, you can see Mount Wellington here. All right, number 10, Mount Smart. And number 11, Mangere Mountain. Okay, all right, so those are our mountains, our maunga. So let's now look at our 2 islands. So the photos of the islands that are on Wikipedia, I didn't like that much in terms of being, well, you might like them, but these are 2 from the water. So number 12 is Browns Island. Does that look like a volcano? Yes or no? And number 13, Rangitoto. All right, and our last little bit of data gathering is going to be our water. So we're going to start with number 14. This is Lake Papuki. This is an aerial view of it on a map, and this is a picture of it. Does that look like a volcano? Yes or no? Number 15, Panmure Basin, which is this piece of water here. Number 16, Mangere Lagoon, which is this piece of water here. And number 17, Oraki Basin.
I'm so curious. 16 got all yeses. I'm wondering if it's that little island in the middle that made folks say yes.
Cool. All right. So that was awesome data gathering. So I think we're just going to now move into a little bit of a handover between, at the moment, between Letitia and I. And we're going to do some work. Is that right, Letitia? Because we actually now need to send them to
CodeApp.
CodeApp or to the document.
They can go to the document. Yeah.
We haven't put the link for the document in, have we? Let me just get that. This one here, share. Copy link. Done. Chat. Here we go. Link to the document in there.
And we're going to actually work and look at some of the data that were collected from those cards that we pre-populated. And you'll be able to access the CodeApp document yourself by clicking on the link that's I've highlighted, item number 5. Two different ways. You can either do synchronized swimming, which means I'll show you my screen and you can follow along with me. Option 2 is just to watch because maybe you're outside and it's glorious and you're on your phone and don't have enough screen space. And then option 3, if you're someone who likes directions, on the following page, there's kind of step-by-step directions if you're someone who prefers to use technology with text. So we've got kind of 3 different ways to play today. And hopefully, let's see. Did I manage to share the right screen? Can you see my CodeApp screen?
Yes.
Okay. I used to have this beautiful bar that told me which of my 2 screens is being shown, but I don't have it anymore. I never know. All right, so Volcano 1, we have our base data set from Wikipedia. And as you were responding to the chat, I was inputting these values here to Volcano yes or no based on the photos. And then I went up and I updated the shared view link. So hopefully it has updated in time. It usually takes about a minute. And we collected some of the data from the data cards, such as what was the name in English, what was the name in Maori, but not all of the data cards had the same types of data. And so we were feeling a little unhappy about the data set. And then Sherry, she did some work on the internet and discovered a second data set. And it was from the Smithsonian. And it was a much larger data set, but it had some classifications, like what type of volcano was it? And it also had elevation. And you'll notice that this latitude and longitude is in a different format than what some of these cards were. So I don't know if you noticed that on the data cards, some of them used minutes and seconds, some of them were in decimals, some of them were incomplete. So what I'm going to show you now is 2 different ways we can join these 2 data sets. So we have a cleaner data set that we can investigate and be more curious about. So the first, and I just learned about the second one from Bill Fenzer, who made CodeApp yesterday. So the first step is I have just named my data sets with a convention that just helps me use this plugin. So you're going to click on the plugin and choose the transformer plugin right here. And we're going to do something called an inner join, which probably as stats teachers, you may be familiar with. But this is a nice tool to combine 2 data sets. And we know in classrooms when students are curious, they ask questions that are often beyond our data set. So in this case, we're going to create a 3rd data set and merge the 2 together. I'm going to choose my base data set as Volcano 1 base Wikipedia by clicking on it. So in the Transformer plugin, if you haven't played with it, there are a lot of different things you can do. We're going to just choose inner join. And then I'm going to choose my base data set to be Volcano 1 base Wikipedia. And my joining data set, I'm going to choose Volcano 2 joining Smithsonian. And then for our base attribute, how are we going to combine them? What are the two things that are in common? We're going to choose the volcano name English for both of these. And once we do that, we apply the transformer, and now we have all of the attributes together in one table. Now, there are really two really great features about this joining process. Whatever you do to these tables here, your base or your joining will update in this third table. So if you go back and make some changes, it will show up. So I can say hello in capital letters, and we can see that the hello on 9 here showed up here. But now we have some cleaning to do. And Pip, do you want me to talk about maybe making some decisions about the cleaning that we might want to make? Or would you like me to?
No, you can do that. And just Mary, to answer your question, yes, you can actually go to a spreadsheet, highlight a data set or the data you want to bring in. And then if you click on the tables at the top, it will say new from clipboard, which I think Letitia's just showing you now. And there's your data come in. So it can be as easy as that, or you can drag and drop a CSV file. There's many ways you can do it, but it can be that simple.
Now, in this data set, you see that we have latitude and longitude there, and then we have it again over here at the end of the table. We certainly don't need it twice if we want to explore this data. And we can't really even use these values because it's missing a whole bunch and they're not in the same formats. So for me, I probably would delete these two attributes and just use the latitude and longitude from the right. Now, something that's interesting about a joined data set is usually you can move columns around, but in the inner joined data set, you can't change the order of the columns. In the HyperDoc that we shared, it tells you how to do that if you want to do it later. But at this time, we can't change the order. But I might want to get rid of this latitude and this longitude. So that way I can actually look at the locations on a map.
And you do need to rename the other two so they're just latitude and longitude. Get rid of the 1. So
My Google is taking a long time to save so it can respond. Oh, I've crashed it. Let's wait a moment. So to rename, you'll click the name of the variable or attribute, and you should be able to rename it, and you'll want to remove the brackets and 1. Pip, you may need to share screen.
All right. Here we go. So I haven't removed mine. That's why I did that. Let me just delete these 2 attributes. And then if you click on the attribute and click on rename, Kodak won't recognize longitude and latitude unless they are exactly those words. But the beauty of having longitude and latitude is that if we do, sorry, I said share, but I didn't share. Let me do that again. So you click on, don't tell me mine's going to do the same. Mine's done the same.
Oh, dueling.
I wonder if it's because I'm sharing. It's just, anyway, you can see I renamed mine latitude and longitude. But yet mine has completely locked up too.
Oh, well, isn't that just the way that it goes when
Yeah, I think it's, wonder if it's because I'm sharing as well and it's taking up a lot of my data.
I do know that a major update is coming through on CodeApp, and it could be that we are doing it live, right? A major update for CodeApp is happening, I believe, today. So that might be. Now, there's a second way to join data that doesn't require the Transformers plugin. And I will go ahead and see if I can get my version to be nice here. And I'm also going to turn my camera off in case it is a bandwidth issue here. So we have this joined data set, and now we have latitude and longitude. We were trying to rename it so that way it would show up in the map, and that wasn't playing very nicely. And I can change, I can hopefully show it on a map. Last time that was a problem. Now making some changes to this joined data set, I would imagine could cause some challenges because it is built off of these other two data sets. And when you're joining two data sets, changing one data set and it now doesn't correspond to the data set where the data came from probably is going to cause some problems. But some nice things about CodeApp is that when we have students or ourselves, we're collecting data, CodeApp will handle mixed data types. So one of the things that you might notice is that on the elevation, we have both numeric data, and then on one of the values, the M for meter is still there. And that can be a really big problem for a lot of programs. It won't display it as a numeric attribute. So here we see 0 meters. So the nice thing that we can do is we can either we can manually go and just delete the M because we don't want it to be there, but we can also tell CodeApp just to treat values as I'll demonstrate this here. So here the elevation, some of the values have meters and some of them don't. And now we can see that CodeApp is reading it as a categorical value because we have all these lines. But we can tell it just to treat all the values as numeric, and it's going to ignore the meters. So we can go ahead and do some summaries about how the elevation varies in New Zealand. So this is a nice tool. Now, there's another way to join the data set for us to maybe be curious, because I mean, the whole point of creating this data set was to think about volcanoes and how the volcanoes in the New Zealand area might differ. Now, I'm going to test my hypothesis because I'm curious, like, why does it keep crashing? And I'm thinking that probably changing the names of these latitude and longitudes, maybe that's the problem. We'll see. Now that I have this updated joined data set, I could definitely make a couple of representations and do what Sherry was talking about, doing some reasoning across representations. Maybe looking at, do we think that volcanoes, we're more likely to say, yes, it's a volcano if it has a higher elevation? Don't really have enough there. I'm still shocked. A whole bunch of you thought that those lakes look like volcanoes, to be honest. When I looked at them, and even though I teach science, I was like, I don't think that these look like volcanoes at all. But that's because I'm outside of Oregon, and I look out, I can see two volcanoes from where I live, and one of which Pip shared at the beginning. Now, there is another way to join data sets, and because this is a topic, joining data is so messy and can be exhausting. Another way that we can join data sets, we can actually drag and drop. So here I have volcano English name. I'm gonna actually close this so I don't crash it. I have the volcano English name, and you'll notice this data set has 54 cases, and the ones that we looked at together earlier, there are only 17. So I can drag and just bring it straight up, and it's going to join my volcano 2 with my volcano 1. And it will bring these attributes over and fill all these values in. But because it keeps crashing, Those values didn't come over. Huh. Well, we're just having a tech challenge day, aren't we? Let's bring up. So when we think about being curious, perhaps we can go back to our recap of the different ways that we see curiosity
Oh.
showing.
Here we go.
So we wanted to name a few of the data moves that we find ourselves often trying or needing to do when we're being curious and trying to create new data sets for explorations for students. Some of them, something that's really fun, and this goes back to our session that we did in February about thinking about photos as a source of data, are sometimes we can pull elements out of a data to create a new attribute. So us looking at all the photographs and then thinking about that as a volcano, yes or no, and classifying them. So using photographs as a source of data is an interesting task. Joining data sets together, that there's two different ways we can bring data sets together to help us explore questions that we have or create a more complete data set. Also, this idea of when we have multiple data sets, we can compare values. So if you spend some time looking at both data sets, you might notice that the elevation listed in one data set differs from the elevation in a second data set. And this is quite interesting. If we do some more digging, we found an error. One of the entries was in feet instead of meters. And so when we will go back and look at the photograph, we realize it is not that tall at all. So there's some errors in the data. And that's you can only really notice that unless you're aware of the area. One way we can find errors is by comparing two similar data sets. And then we recognize that there are different formats of things like latitude and longitude and different preferences. And then we talked about how having characters in the data for other types of programs will return plots that are only for categorical plots. It won't let you move forward with the data. So these are opportunities to work with data. And Tim Erickson, he coined the term data moves. And we just think it's a great opportunity to dig into the data and then allow us to create new data sets for topics that we're curious about.
Okay, so I dropped in. I was just doing a little bit of planning for my workshop tomorrow, and I've put the instructions on how to do the Great Circle distance. But just this is showing the distance to the volcanoes from the Waipuna, which is where I'm going to be tomorrow, and that's by the Panmure Basin, one of our volcanoes that we're looking at. And I used in the sheet that you've got, it tells you how to do the Great Circle distance. It's very straightforward. I'm going to say it is. You put a formula in and then it fills everything immediately. But you can see here, and if I click on each of these, this is not live, so I can't show you, but you can see that from the Waipuna, all the volcanoes we looked at were within 16 kilometers of the place. So this is just 17 of the 53 volcanoes or extinct volcanoes now that are sitting on the Auckland volcanic field. So it's just a nice way of looking at. So sometimes our new variables, we don't have to look at photos. We can think about something, and through using a function or something in CodeApp, we can put some more information in. And one of the things that I've been looking at with schools, for example, is how far is the volcano from your school, and looking at it in terms of the Great Circle distance, and then how far is it if you had to drive. And obviously Rangitoto and Browns, you can't drive to at all because they're islands. So there's some good things for the kids to think about. All right, so Sherry, back to you, I think.
I had the previous slide. My apologies. So we hope that you had a great time thinking about curiosity as we started with one small data set with volcanoes from Wikipedia. And then we found a more extended data set. And this is something that happens oftentimes in the real world. You have two disparate data sources, and you need to be able to combine those. There's definitely more of a data science as opposed to like AP Stat type of activity. But it's also something that is valued in industry, because oftentimes you go to one department to find one piece of information and they don't have everything you need. You have to go somewhere else. So that aspect of combining two different data sets is a really important data move. So from an experience standpoint, we've thought about where data can come from. They can be coaxed from an initial source like a photograph or a name. That we have provided opportunities for students to ask a lot of questions. Even if they can't answer those questions, they're wondering and their curiosity kind of snowballs. Also, in terms of supports and how can we create a data set of organized data. I know thinking of it as like tidy data that can be organized into a table of rows and columns, so then it can be further analyzed, as well as going back to what Letitia said at the very beginning, having an awareness of each person as an individual and different language that is used across each observation. So you are able to manipulate that data in any fashion. So we will open it up to questions or any thoughts that you guys have. How would you use curiosity, or what has this made you think about that you might be interested in trying in your classroom, or what are your thoughts?
And since most folks are in the US from this call, I believe I am also working on another activity. And so in the presentation materials, I have a collection of volcanoes with photographs and data cards that all have the same dimensions. So they all have the same values for different volcanoes in the United States. In case you like to use data cards and or might want to build off of something more regionally. Oh, well.
Questions, anyone? You must have just wowed them to where they don't have any questions. This was a great presentation. How long would you, one question I've thought about throughout this, as teachers trying to put together these types of activities takes time. How could you maybe estimate the time that you've put into putting together just this activity in this presentation?
Well, it depends on whether we're focused or we're distracted, but we've had 3 or 4 meetings. We've had about 4 meetings of about an hour plus what we've done in between. But a lot of some of that was perhaps going off on tangents. I think the thing that is nice about what we do when we work together is that the collective ideas that we have are way better than if we were just chipping away by ourselves. And I think that's where we started, you know, when we did that original session about using photographs, we took the same prompt, but went 3 different ways. And so that's what I really love about working with Sherry and Letitia. And so I'd really recommend, if you want to look at things like this, the other thing is to find a buddy or 3 and actually pull. The other thing too is once you've got it made, it you can use it many times, I guess, is Yeah. And I'm
Well-
just gonna sorry, I'm just gonna drop a link in the chat to a series of videos I made at the beginning of COVID for teachers in New Zealand to support them getting their kids started with Kodak. So if they're useful to you, you're welcome to use them with your students. It's a Google Sheet. You can copy it and edit it how you like. Just a bunch of little short videos on the different introductory things you can do. Yeah.
And,
I
and
think
maybe
every
Mary,
time I'm reminded of how difficult it is to do some of the data wrangling. I know we had on one of the last slides, but you guys didn't see the data from the Smithsonian actually came with the elevation as 40M. So in Excel, you can't, or in Google Sheets, you can't really do a numerical calculation on it because it's not a numerical field. Well, we could use some different formulas and string functions, but then we come to find out I'm playing around with it and I'm like, oh my gosh, if I have this in CodeApp, I just change that variable to a numerical type and it stripped away all the meters. But then the GPS coordinates were a different story. I didn't find something as helpful in CodeApp. In the Smithsonian file, they were in the degrees, minutes, and seconds. So I was able to use a column to text using delimiters of, you had to actually copy and paste the actual character, because if I typed the degree symbol, it didn't recognize it as the exact character, but allowed that to separate it into columns and then use a calculation to convert it. But it's always a reminder of, you hear from statisticians who get out and start working in the field that they spend so much time preparing the data and developing those skills and making teachers and students cognizant of those, I think is something that we need more of.
and I think we've got an idea here, Chris, for a session about bring your own data sessions. So maybe we could in the future set up where folks maybe have a data set that they're kind of curious about or wanting to build something. And maybe we could break out into some breakout rooms and do something similar to where we try to impart some structure that we think might be useful together, or search for some data together and build something.
I think it's a great idea.
BYOBD, bring your own beverage and data.
I like that.
I've just dropped a link
Cheers.
in the chat for the Data Gem stuff that we did in New Zealand for teachers, because we in all our years of schooling we teach statistics, but in our last particularly 2 to 3 years we assess against statistics, and they're always looking for data sets. So there is a bit of a focus on New Zealand, but there are some international ones there as well. So if that's useful for people.
I actually used one time some of your data for, well, I don't know if it's your data, but they had information on agriculture, and it was specifically about cow farms. It was like dairy farms, and they had already prepared the data so they could see what was happening with the cow's milk. And like the kids had to find out, what do you think happened? Why is there no milk? And it turns out like one of them died, one of them had a baby. And I forget, but there were different things, and the kids had to figure out, why is this cow not making milk anymore, you know? And it was really interesting. It was, the data was great from wherever it was that I used it. I didn't do that project in a couple of years, but I just try to mix it up.
Oh, cool. So I've just dropped a couple of others in. So on Census at School in New Zealand, we now house all of the international data sets, databases for the Census at School project, including the US. And we have New Zealand data. And then I've also put the specific link to Stats Otago, where they have videos and data sets that you can use. So yeah, it's not easy. But I think having a share session where we bring along data sets and we share them is a great idea. Yeah.
Well, a lot of time I get them from like, oh gosh, I wanted to say Zillow. That is not right. What the heck is the data set I use? Oh boy, it's not coming to my mind. It's been a long day. But when I get it, it's huge and I have to parse it and I have to organize it. And it takes a long time to get it usable. I love doing it, but it's like, it's forever. This is like what I do. If I teach 5 classes and only one is a data class, and it probably is 99% of my time.
Yeah, I have a project, which I need to go in a moment for, but it's an NSF funded project. And right now we're looking at prepping data sets, science data sets for K-12 spaces. And they'll, from like getting it from a scientist all the way to getting it ready to give it to a teacher, and no lessons, anywhere from 10 to 100 hours of cleaning and prep. It is a big task. And so I think doing some of this work together and also having a chance to bring disciplines together. There's a pocket of science data sets, there's pockets of stats, and often we don't know about each other. So sometimes we can get increase our N really quickly when we're in different rooms talking about data.
Tisha, wasn't there a post recently to some of those data sets or some stuff you've been doing about data sets in Kodak?
Yeah, so in the ASA notes that we shared with y'all, I've been putting the links that Pitt put in the chat there. And so we have a part of this NSF project that we're testing, and they're called data biographies. So they are data sets that have been cleaned up, some data collected by students and some from other sources. But they also we're testing what are some of the wraparound materials that teachers need to know about the context of the data. Most educators don't need like the scientific metadata, but we do need to know about some of the collection processes and some things about the units in order to do productive work with students in the data. So it's a prototype. And so there's some of those there, and those are called data biographies from Concord. And those are in the presentation materials linked as well.
You got the wrong link though.
Okay, I will fix that.
Well,
So
I
good.
probably should end the chat. We've run over our time, but thank you again, Sherry, Letitia, and Pip. Pip, thank you for getting up early in New
This
Zealand.
was 10 a.m.
Oh,
It's not
that's
too bad at all.
right. I get so confused with daylight savings times, how much time difference there is. But thank you again. And thank you everyone who joined us today. And our next K through 12 chat will be on April the 18th. So you'll be getting a notice, but mark your calendar. Okay, so long, everybody.
Bye.
Bye.
Gotta go, everyone.
You stop recording.
I did.